which means where am I reflecting these points or shapes? Okay, so this is the line that separates a point, a line, or an object and its image. So it's basically your mirror in this case. Okay, it's like the mirror, like where are we reflecting this? And that is the mirror. And then, of course, the mirror image is the new position of the point or the line or the object after you reflect it. Okay, so these are the two important things we're going to be speaking about today. First reflection we're going to speak about, there are 3 reflections in total. Okay, the first one we're going to speak about is the reflection about the x-axis. And we all know that the x-axis is the horizontal axis, that one over there. So let's look at this triangle over here. We are reflecting triangle ABC to A prime, B prime, C prime, which will be at the bottom because X is our mirror. So obviously you expect your image to be at the bottom. Now look what it ends up looking like, right? You're not just moving the shape to the bottom, right? You are reflecting it. It's like a mirror image. So if triangle ABC is reflected about the x-axis to form the new triangle, then the second coordinates of the triangle will differ in sign. All right. So let's look here. The coordinates of A are negative 6 and 5, and A prime will be negative 6 with negative 5. So the coordinate that changes in sign is your y coordinate. Okay, which makes sense, right? You have moved it down, well, it's down along the y-axis because x is your mirror. Same thing with B. It moved from negative 6, 2 to negative 6 and negative 2. And final one from negative 2, 5 to negative 2 with negative 5. Now, this is important, something that you guys need to be careful of. We do not make the coordinates negative. That's not what we're doing here. Okay, they change in sign. So had this triangle had negative coordinates in the beginning, then the new triangle would have positive coordinates for the y. All right, so be careful of saying you're changing the sign to a negative. I know it's easy to fall into that trap. We're not doing that. We're changing the sign. Okay, so this is what it will look like for point P if we're reflecting it. As we said, the line of reflection is where you are reflecting it. And apparently I can't draw a straight line. Let me fix how this thing is sitting. Okay, so in this case, your line of reflection will be the x-axis. And if you look here, your point will be the same distance from the line of reflection on both sides. What I mean is, let's look at the point P, right? It will be 1, 2, 3 units away from my line of reflection or mirror, which means P prime will also be 1, 2, 3, just in the opposite direction. Does that make sense, guys? Okay. And then the second one we're speaking about is reflections upon the y-axis, or about the y-axis. And we know the y-axis is your vertical axis. All right. So once again, look at this triangle. This was the same one that we had previously. Now, the only difference is our mirror is the y-axis. So the point ends up, or the shape ends up on the other side of your y-axis. Does that make sense? And if that happens, that means it affects the x coordinate. And this is what I was talking about. Remember, all our x coordinates were negative. The sign changes. So it went from negative 6, 5 to positive 6 and 5. Okay, from negative 6 and 2 to positive 6 and 2, and from negative 2 and 5 to positive 2 and 5. Now take note, only one of the coordinates change. Okay, if you change both of them, that is a different type of transformation, which is not what we are doing here. All right. Again, our line of reflection, y-axis, same distance away from the line of reflection, 1, 2 units, 1, 2 units. That would be t and t prime. All right, guys. Does anyone know what the third type of reflection is? We've done reflections about the x-axis, reflections about the y-axis. What's the third type? Where else can we reflect these shapes? Does anybody know? Anyone who has done this in school before, what is the third way in which we can reflect shapes, points, or lines? Anyone? Nobody knows. Okay, so the third type would be reflections about the line y equals x. Okay, now that line would be this one over here. Okay, and it is the line y equals x because whatever x coordinate you have, the y coordinate is the same. Let's look over here. That point there would be 2, 2. Here would be 3 and 3, -1 and -1, -2 and -2. So it's the line that forms when y is equal to x. And in this case, we have a little bit of a more interesting dynamic with our coordinates, okay? Now what happens here is your coordinates will swap. They will change places. So if you look at this point B, okay, B, this is the, I know this bird wants to learn mathematics. For free, imagine. Birds are going to take over one day, guys. Okay, so we go from -2 and 3 and we swap them. So your x coordinate becomes your y coordinate becomes the x, and your new coordinates will then be 3 and -2. There are no sign changes. You just swap the coordinates. All right. So let's look at here the first activity that we have. Write down the coordinates of the image of the given point if the point is reflected about the y-axis and about the x-axis. States the general rule of reflection in each case. Okay, so I'm going to say reflection here. The reason I have two sides is because we're going to do reflection on the y-axis on one side and reflection of the x-axis on the other side. Okay. So I'm going to write reflection y here and reflection x. Okay, now our general rule for reflecting upon the y-axis. I'm going to start with that. We're going to go from x, y. Which of these two coordinates change signs if you reflect upon the y-axis? If you reflect on the vertical axis, which of these two coordinates will change signs? Let's hear, guys. The x coordinates. So then it's -x and y. And then, of course, reflection about the x-axis. We go from x, y. And which of these two are going to change signs? The y coordinate. Now, you might be asking why I'm writing -x here and -y, because that implies that we're making them negative, but it actually doesn't. Because let's say you have a coordinate that is 4 and -2, right? What happens if I put a negative in front of -2? What happens? That negative situation, it becomes a +2. Do you see the point of this negative that I have written over here? So I'm not saying you make the coordinate negative. I'm saying you change the sign. You need to learn this notation well. Okay. So that's our general rule. So let's reflect all the points. A, B, C, and D. So we're going to go from A, which is 3, 4. And A prime will become, if x changes signs, it will become -3 and 4. Are we with me? And then we have B, which is -3 and 4, which means B prime will be what? What are the new coordinates of B prime? If we're reflecting about the y-axis, what are the new coordinates, or rather the coordinates of B prime? It will be +3 and +4. Be careful. Only one of them are changing signs, and that is the x coordinate. Okay, that's why we're doing this activity. C goes from -3, -4. What are my new coordinates for C prime? My new coordinates for C prime, if only the x coordinate is changing signs, you need to look very carefully here. Yes, Bohlali. It will become a +3 with a -4. And finally, D is 3 and -4. What are my coordinates for D prime? Thank you, Seth. -3 and -4. So if you look carefully, all your x coordinates have changed signs. Okay, now let's reflect them upon the x-axis, which means my y will change signs. So A, again, we start at 3, 4. What are my new coordinates for A prime if it's reflecting on the x-axis? X-axis. What are my new coordinates? This time your y is changing coordinates, right? Yes, so it'll be 3 with -4. Wonderful. Welcome, Nolwazi, to the answering squad. I love it when people answer. B is going from -3, 4. What is my coordinates for B prime if I've reflected it? It'll be -3 and -4. C goes from -3 and -4. New coordinates for C prime. -3 with +4. I don't think it helps that they use the same numbers here. It's confusing everyone. And D, 3 and -4 reflected upon the x-axis becomes, yes, +3 and +4. And if we look in this case, all of my y coordinates have changed signs. Can I get a thumbs up, thumbs down on this whole concept of reflection? Lovely. Wonderful, guys. Great. Okay, now we're going to practice reflecting upon the line y is equal to x. Remind me again, what is the rule for reflecting upon the line y is equal to x? If I start off with x, y, I'm going to end up with what? What are my new coordinates going to look like? What are my new coordinates going to look like? Using x and y, tell me what the new rule is when we are reflecting upon the line y is equal to x. No, it's not. There's no sign changes, remember, Seth? But what happens? You can say it in words or you can write it in notations. What happens when we are reflecting upon the line y is equal to x? Nice, Bukhale. So it goes from xy to yx. They are swapping positions. Okay. Nice. We're getting used to this notation thing. Great. So let's start off with 1, which is point A, 5, 7. Tell me what the coordinates of A prime will be. Coordinates of A prime will be what? 7, 5. Nice. Okay, so we're literally just swapping the numbers. No sign changes. Absolutely nothing. Just swapping the coordinates. B starts off at -5, 7. What are my coordinates when I reflected? 7 and -5. Number 3, C starts off at -5 and -7. Nice, Seth. I forgot to write B prime here. I was wondering what's missing. B prime, 7, negative 5. See, guys, when you guys answer right and you make me excited and I stop writing the right things. C prime becomes negative 7 with negative 5. The next one, which is point D, starts off at 5 and negative 7. D prime will end up at, now there's a lot of answers. I'm not sure where I'm going here. D prime. Can I have the coordinates for D prime, please? Thank you. Negative 7 and 5. And number 5, E starts off at 4, 0. And E prime, 0, 4. And finally, number 6, I'm going to write it here. F starts off at 0 and negative 4. And we end up at F prime, which is negative 4 and 0. Can I get a thumbs up, thumbs down on reflecting about the line y is equal to x? Okay. I think this might be the easiest of the reflections, okay? With the other one, you might be tempted to change the sign of the wrong one. For instance, if you are reflecting on the x-axis, you might be tempted to change the x-coordinates. So be careful of that. All right. Now, they've given us a bunch of reflections and they want us to tell them, has this been reflected upon the y-axis, the x-axis, or the line y is equal to x? Okay, let's start off with number 1. A has been reflected from 7, 3 to 3, 7. So which type of reflection is that? Is it x-axis, y-axis, or y is equal to x? Nice, Seth. We've reflected this upon the line y is equal to x. Great. Number 2. Went from 2 and negative 8 to negative 8 and 2. Where has this been reflected? Again, y is equal to x. Number 3, negative 7, 3 to 3, negative 7. Again, y is equal to x. Number 4, negative 4, 5 to negative 4, negative 5. X-axis because your y has changed signs. Nice. So this is upon the x-axis, excuse me. Oof. Number 5, from negative 4, negative 5 to 4 and negative 5. Where has this been reflected? Nice. So up here, this is your y-axis reflection, because your x-coordinates changed. And the last one, from negative 4, negative 5 to negative 4 and positive 5. This is reflection upon your x-axis. I love it. All right, so it seems we're getting used to this. Swapped coordinates, y is equal to x. Different x-coordinate, y-axis. Different y-coordinate, x-axis. Okay, are we all with me still? Can I have a thumbs up, thumbs down? I know we answered that very quickly, but I just want to check that I haven't lost anyone, okay? If you don't understand where you're lost, just don't be shy to give me one of thumbs down so that I know and I can explain to you. Wonderful, wonderful, wonderful. Okay, so anyone who wants to take a screenshot of the summary, this is a summary of the 3 reflections, so that you just have it. Okay, so that you just have it. This is your summary of reflection. All right. Now we're going to reflect all of these points on the line y is equal to x. Okay, so I have A, B, C, and D. First, I'm going to write down the general rule. X, y becomes y, x. I am doing this so that you see where the points end up. Okay, so when we're reflecting upon this line, they need to be on opposite sides of this line. So that's why we're doing this, okay? So A. A, we're starting off at negative 3 and 4. What are my coordinates for A prime? My coordinates for A prime, if we're reflecting about the line y is equal to x, 4 and negative 3. Yes, that means it will end up 4, negative 3. It will end up over here. This is A prime. Nope, I shouldn't write with a cookie. It looks terrible. A prime. Great. Point B, we're starting off at negative 5, 2. What are my new coordinates for B prime? Let's see. 2, negative 5. Nice. Which means it ends up over here. And that is your B prime. Okay, point C, 0 and 3. C prime ends up at 3, 0. Okay, 3, 0, which is over there. And this is my point C prime. And the last one, point D, we are starting off at 6 and negative 2. We're going to end up at D prime, which will be at negative 2 and 6. I don't want to write in black because then you're confused. Negative 2 and 6 over there. And this is the point D prime. Okay, what can you guys say about the quadrants? What can you say about the quadrants where these points end up? What do we think, guys? It is the opposite one. The one right opposite to the original point. Okay, so if it's there, it ends up over there. If your point was in here, there's actually a fourth type of reflection, but you guys don't do it, and that's the reflection upon the line y is equal to negative x. If your point was here, it would have ended up over there. Are we with me? Okay. Great. Now, we're going to practice this whole shenanigans with an actual shape because, I mean, obviously, we're not just going to be reflection points. We're going to have to know how to reflect entire shapes. So draw the line y is equal to x and y is equal to negative x. Now, I'm going to draw in y is equal to x first before we speak about the line y is equal to negative x. Now, I need to make sure that I'm drawing a straight line here. I'm going to start, maybe I should start at the end and go straight through. Yes. It is mostly straight, not really straight. And now my OCD is taking over. There we go. That's my line. And when you do this in a test paper, please label your lines. So you write here, this is your line, y is equal to x. Where do you think the line y is equal to negative x is going to be? Where do you think the line y is equal to negative x is going to be? It's here. Anyone? The line y is equal to negative x. Let's actually practice using coordinates. If I have the coordinates 2, no. If I tell you that x is equal to 2, what will the y coordinate be here? For y is equal to negative x, what will the y coordinate be here? Anyone have an idea? Yes, to me it will be negative 2. And if I tell you that x is equal to negative 4, my y coordinate will be what? My y coordinate will be Positive 4. Nice. You are pure and to me. Okay, so that puts the line where? Here. Look, 1 is negative 1. 2 with negative 2. That just means that x and y are opposite signs. So that means that places my line over here. It's the other way around. Does that make sense, guys? Before I move on, can I have a thumbs up, thumbs down on the whole concept of the line y is equal to negative x? You need to know where that line is. Okay. Do you guys agree that we've actually created another Cartesian plane now? It's now just in the opposite direction. It's tilted a little bit that way, but it's technically a Cartesian plane. Okay, so once again, label. So this is the line y is equal to negative x. And of course, I must write my x like that. X. Great. That was instruction number 1. Number 2, draw a triangle T with the following vertices. So let's draw our triangle. Okay. First one is at 1, 1, which is over here. 3, 1, which is over there. And 2, 2, which is over there. It's a very small triangle, but you know, following instructions. Maybe I should use a different color so that you guys can see the triangle. Let's use green. So it goes from that point to that point, which is not straight, which is making me lose it. There. Insert another one over there. And insert another one over here. That is our triangle T. Okay, so it says label this triangle T. Great. And then it says reflect T in the x-axis and label the image U. So first we're going to do calculations over here now, okay? So when we're reflecting on the x-axis, which of my coordinates will change signs? I'm going from x, y to x negative y. Nice, Seth. So that means I'm going from 1, 1. What are my new coordinates for this point? My new coordinates for this point. Nice, you are pure 1 and negative 1. And then the next one, we're going from 3, 1 to what? 3, 1 to what? 3 and negative 1. That is true. And my final one, I'm going from 2, 2. What is my new coordinates that I've reflected? 2 with negative 2. Great. Now let's draw in our new triangle. So I have 1 with negative 1. That would be over there. 3 with negative 1, that would be over there, and 2 with negative 2 over there. So it's basically the upside down version reflected upon the, there we go. So it's there, over there, and over there. There is my new triangle, which we have been told to label triangle U. Okay, and then the second instruction says reflect U. So we're reflecting this triangle in the line y is equal to negative x and label the image as V. Oh, isn't that interesting? Let's come up with a general rule here. X, y. How do we reflect something upon the line y is equal to negative x, which is this guy over here? Where will this end up? What do you guys think? What do you guys think? Y is equal to negative x. Yes, y is equal to negative x, but that is our line of reflection. Do you guys agree? That is our line of reflection. So where do we put this shape? What will my general rule be? Anyone have an idea? Okay, so it is a combination of rules that we have already spoken about. Okay. Ew. It is a combination of rules that we have already spoke about. So what did we say when you were reflecting on y is equal to x? Bohlali has the first part of this, right? So first we're going to swap the coordinates. It's going to be yx. But what else are we going to do? It's going to be yx, but what else are we going to do? We're going to change the signs. So it's negative y and negative x. Oh, isn't that interesting, guys? So first, we swap them, and then we change the signs. Does that make sense to you guys? Let's practice. Okay, so I'm starting off. Let me first write all the coordinates. 1, 1, 3, 1, and 2, 2. Great. So first we swap. Okay, 1, 1, but we swap them. Okay, use your imagination. We swap them, and then we change the signs. So what are my new coordinates going to be? Both of them have to change signs. So what are my new? Nice, Seth. Negative 1 and negative 1. Great. Let's go with 3, 1. I think this coordinate is the only one we were going to see an actual change. So first swap, then change the signs. Swap and change signs. Nice. So first we swap. So 1, 3, and then we change the signs. Negative 1 and negative 3. And the last one, the swap again, you don't see. But what is our new coordinates? Thank you, Buhlali and Seth. Negative 2 with negative 2. Let me look for a new color that I haven't used here. Orange. Okay, so this one will be at negative 1 and negative 1. Negative 1 with negative 3. And negative 2 with negative 2, which is over there. Peach. I said orange with so much confidence, but it's peach. You guys get the point. There. And there. And there. Okay. Can I get a thumbs up, thumbs down on this, please? You guys can screenshot, zoom out. I'm thinking about what I'm doing here. You guys can screenshot. Okay, it's getting a little bit more interesting. Don't you guys agree? It's getting a little bit more interesting. Okay. We have another shape here. It is a triangle. We're going to stick to triangles for today's lesson. But you know, at the end, we usually do like problem solving questions. Then we'll have more interesting, like at the end of this chapter. Okay. But we're going to stick to triangles for today so that we get a proper grasp of the rules. A. Draw triangle ABC. Okay, I don't have to write A here. I'm drawing a triangle at the following coordinates. Negative 6, 5. Negative 6, 5 is over there. B is negative 5 and 2. and C is negative 2 and 2. So that's a bit of a different triangle from the ones we've been drawing this whole time. It's slightly slanted. What type of triangle is this? Let's see if we remember. Look at the angles that are in this triangle. What can you tell me about this triangle? What type of triangle do we have there, guys? We did this. Let's hear. It is not isosceles. Well, we're not sure until we work it out whether it's isosceles, but I'm talking about the angles. What can you tell me about the angles? It is an obtuse triangle. Beautiful. Okay, and then B says draw the image of ABC, which is A prime, B prime, C prime, if this triangle is translated using this following rule. What does that rule mean? Where are we reflecting this? Look at the rule that they gave us there. Where is this reflection happening? Anyone? Look at the general rule that I've highlighted in yellow. Is this a x-axis, y-axis, or y is equal to x reflection? Y is equal to x. But yes, Butlali, you are correct. So I'm going to insert the line just so we get into the habit of drawing our line when we are reflecting. Okay, so it's this one. That's where we are reflecting. And this is the line. Y is equal to x. Great. I think I can zoom in now so that you guys can see what I'm writing. Okay. So point A, we're starting off at negative 6, 5. What is A prime? A prime is 5 and negative 6. Okay. Point B, we're starting off at negative 5 and 2. Where is B prime going to be located? Remember, no sign changes, right? Yes, at 2 and negative 5. And point C is at negative 2 and 2. Where are we moving it to? 2 and negative 2. Oh, there's so many 2's that I'm saying. I'm starting to confuse myself. Where are we moving it to? 2 and negative 2. Whew. Great. Let's draw this new triangle. Okay. I actually think it's a good idea for me to write down that this is A, B, C, so that in the new one I can write down that it's A prime, B prime, C prime. Okay, this time we're starting at 5 and negative 6. We're all the way here, and this is A prime. Then we're going to B prime, which is at 2 and negative 5. And then we're going to the next one, which is at 2 and negative 2. C prime. There we go. Insert. There we go. There. And there. And that is my new triangle. And then C, are these triangles similar or congruent? Are these triangles similar or congruent? Anyone? Are they similar or are they congruent? Do me say similar. There's 18 of you in here, so I'm expecting more responses. Let's hear. Seth says congruent. So we have one vote each. So Siwa Piwe says congruent. Elam says similar. Olwazi says similar. We're still tied, guys. It's 3-3. Come on. We are now tied. 3 for similar, 3 for congruent. The rest of the class, let's hear from you guys, please. We're so quiet. Elanda, Logan, Bonang, Blessing, Andile, Hapais, Samulo, Neo. We just need one vote to break this tie, guys. Similar or congruent? Nothing. We are watching SpongeBob during the lesson. I'm kidding. These are, in fact, congruent. Why do I say they're congruent? People who answered congruent in the chat, can you give me can you tell me can you give me an explanation about why you are saying these are congruent? My English took a short left there for a while. They're congruent because it's the exact same triangle, right? All we did was reflected. Remember, similar means the sides are in proportion, so they are not the same size. But these are definitely the same size. If you went to measure the sides, you will find that they are the same size. Okay, wonderful. Let's do another one. Now this time, okay, I need to move this to make space. This time, we are going to be performing quite a few reflections, but let me not get ahead of myself. Let me first just draw the triangle, right? Draw a triangle PQR. Corners of the vertices are -3 and -1, so that's over there. -2 and -1, that's a very narrow triangle. And -1 with -3 over there. It's a very small triangle. Oh, nope, I wasn't supposed to draw that. That was surprisingly a very straight line, eh? Surprisingly, knowing my track record with drawing lines. There's my first triangle. Okay, now they say draw the reflection, but it has to go through all of these transformations. So how many triangles am I drawing here? Read carefully and tell me how many triangles I'm drawing. Anybody? How many triangles are we drawing here? Sally says 2 question mark. I'm saying besides the first one, ne? How many new triangles am I drawing? Let me say it like that. How many new triangles am I drawing? 3, 4, 3. I am in fact drawing 1 triangle because first we're going to take the coordinates and then reflect them, and then take the new ones and reflect them again, and then take the new ones and reflect it or translate it. This is a translation. And then take the new ones and reflect it again. Do you guys see that this is 1 triangle? I am just performing a bunch of transformations on the same triangle. Do you guys see that? Can I get a thumbs up, thumbs down? This is 1 triangle. So you need to read carefully in a paper because teachers will try to trick you with such questions. Teachers is me, but you need to read carefully. Are you with me? Linopta's laughing. I am the teachers I speak of. So let's do it. Okay. I'm going to write it up here because it seems like we're going very far here. Okay. So P -1, Q is -2, -1, and R is -1 and -3. Let's do the first transformation. So the first one says change your x coordinate. Is that a reflection on the x-axis, y-axis, or y is equal to x? What type of reflection are we doing first here? Is it a reflection of the x-axis, y-axis, or the line y is equal to x, or the line y is equal to negative x? Now we actually have 4 options here. What type of reflection? Just look at it, guys. Only the x coordinate changes signs. So what type of reflection is that? Come, guys, I'm going to wait until you answer before I continue with this. It is y-axis. Nice, Bukhali. So this is your y-axis reflection because your x changes coordinates. So then, p prime, the new one, will have what coordinates if we're changing signs here? P prime will have what coordinates if we're changing only the x coordinates? There we go. 3, -1. What about q? What about q? 2 and -1. And the last one, r, 1 and -3. Great, we've done the first reflection. Second one says xy moves to x -y. First, tell me what type of reflection that is. Excuse me. Tell me what type of reflection that is, please. Y is changing signs. So that means where am I reflecting the shape? X-axis. Nice, Bukhali. Okay. So now this is our starting point. 3, -1, 2, -1, and 1, -3. Where are these going? Where are these going? First one, y changes signs. So first one will be 3 and +1. Tell me what the second one will be, please. The second one, 2 and +1. And my final coordinate, is Buhlali the only one left? 1 and +3. Great. We've done the second translation reflection. And now we are translating. We are moving them. Do you see this? We are moving them. So now we're starting from these ones. 3 units to the left, 2 units down. So it'll be 3 units to the left, 3 minus 3, -1 minus 2, 2 minus 3, -1 minus 2, and 1 minus 3, -3 minus 2. Great. New coordinates for the first one. Our new coordinates for the first one. 3 minus 3, it's 0 and -3. Thank you, Bukhali. Second one. Second one. There will be -1 and -3. That's -1 because it's 2 minus 3. And the last one will be -2 with -5. Great. We have done the third transformation. And now we have the last one. Where am I reflection that one? Look at the coordinates. This was a translation. Final one, where are we reflecting it? If xy becomes yx, where's the reflection happening? Yes, the line y is equal to x. So my final coordinates now, I'm going from 0, -3 to -3, 0. From -1, -3 to -3, -1. And finally from -2, -5 to -5, -2. Let's see where this triangle ended up after all that movement. -3, 0, so it's on the axis. -3 with -1, so it's over here. And -5 with -2, so it's over there. That was a lot